Hi everyone. Today our topic is semiconductor devices. Semiconductor devices means devices which depends on semiconductors. Generally, all the substances are mainly divided into three types. They are conductors, semiconductors, and insulators. We know about conductors. So those are the substances in which maximum current flows, like copper. All metals are best examples for conductors. Insulators are the substances in which no current flows, like glass, rubber, plastic, diamond. It is also a best example for insulators. So between them a substance lies, what we are going to call them as semiconductors. So semiconductors are the substances whose flow of current lies between conductors and insulators. In other words, instead of current, a physical term called as conductivity, we are going to call it as conductivity. It is going to be used in semiconductors. So now, semiconductors, substances whose conductivity lies between conductors and insulators. What is the use of using semiconductor devices? If you are going to take a phone, whenever you press the phone, we will see the light. That is due to LED which is present inside the mobile. LED, light emitting diode. During olden days, some 15 to 20 years back, whenever we are going to see TVs which are very big in size, now those TVs are converted into simple LEDs, simple LCDs. Monitor screens of computers, televisions are purely made with LCDs, liquid crystal display. All these LEDs, LCDs are completely based upon semiconductors. And one more important point is, when compared to conductors, insulators, semiconductors we have some specific rule, some specific properties. What is the property or what is its importance? See the first point here. It controls the charge carriers. Suppose for conductors, the first example is copper. If we take a copper wire, current will flow from left to right or from right to left. Whereas in semiconductors, current will flow only in one direction. It moves from left to right only. Current is flowing from left to right. There is no tendency for the current to flow from right to left. So semiconductors have one-dimensional current. So we are going to call it as unidimensional current. Uni means single. So current flow will be from one end to the other end. It can't flow in the opposite direction. Opposite direction flow of currents takes place only in conductors. And one more point is, it controls charge carriers. Charge. Positive charge, negative charge, neutral charge. Positive charge generally we call them as protons. Neutral charged particles are neutrons. And negatively charged particles are called electrons. But in case of semiconductors, we should not use electrons. Holes. Any particles which have positive charge, instead of protons, we should call them as holes. And the particles which have negative charge are called as electrons. So holes have positive charge and electrons have negative charge. So these are what we are going to call them as charge carriers. So in case of semiconductors, current flows only in one direction and the charge carriers gets controlled. So these 2 points plays a very important role in case of semiconductors. Now coming to before these semiconductors, if you are going to tell somewhat the conductors, before these semiconductors, vacuum tube technology plays an important role. Just now we discussed the TVs which we are going to see, which are very very big. Those TVs those TVs works under vacuum tube technology, which is also called cathode ray tubes, or simply we call them as valves. We heard the word valve. Valve is just like a cycle tube valves, where we can send air from outside to inside. So that is what we are going to call it as valve. So before semiconductors, in order for flow of charge carriers, we are going to use a technology called as vacuum tube technology. So if you look at the diagram of vacuum tube technology, see, just here, it contains a plate called as cathode. It contains one more plate called as anode. And this vacuum tube technology contains a heater. Here, this cathode is coated with barium oxide. What is the use of this barium oxide means? Whenever we give some amount of heat to barium oxide level, automatically this barium oxide will make the electrons to emit outside. So, for this sake, cathode is coated with barium oxide. So vacuum ray technology contains, or vacuum tube technology, or cathode ray technology contains a cathode, anode along with a heater. Whenever we give some heat which contains a layer of barium oxide, absorbs the heat and starts emitting electrons. These electrons will move from cathode to anode. Between them, there lies a medium called as vacuum. If there is no vacuum, automatically the electrons will collide with air molecules and automatically there will be a energy loss. So to reduce these energy losses, we use a medium called as vacuum. So in case of cathode ray technology, vacuum is most essential to decrease the energy losses. So what happens? Whenever we are going to give some heat from the heater, this heat is absorbed by the barium oxide layer of the cathode and emits electrons. These electrons will reach us anode using this vacuum. So it obeys the 2 points which we discussed for the flow of charge carriers, and the current is one dimensional. See, current moves in one direction from cathode to anode, and the charge carriers, which are electrons, are controlled. So in such a way, the cathode ray technology or vacuum tube technology, which are simply called as valves, are responsible for the flow of current from one capillary to another. Even though there is a flow of current using this technology, it contains a number of drawbacks or disadvantages. What are these disadvantages means? Here, without heater, we can't heat. So this complete technology depends on heating effect. And vacuum is mandatory, vacuum is required. So it depends on vacuum creation. Without a voltage or without a potential difference between cathode and the anode electrons are not emitted. So it requires some voltage, and almost that voltage is equal to 100 volts. So minimum 100 volts is required to emit the electrons from cathode to anode. And this complete vacuum chamber is very larger in size and requires power, and here more power consumption takes place. When our consumption of power is more, automatically lifetime is less. So less lifetime, and finally leads to less reliability. Even though the current flows, but still there are some drawbacks whose size is bigger, more power consumption, less reliability, less lifetime. Hence, this vacuum technology converted into semiconductor technology. So that is the advancement of semiconductor technology, where all the mobiles, all the LEDs, all the solar cells, and even while we are going to send some satellites are completely based on semiconductor technology. Quantum physics starts with the basic point of semiconductor technology.